In this video for Positive Maths, we're going to look at the final part of an exam question for complex numbers. So this is 2012 paper 1 question 4, and it's part C. So it says, if we let W be equal to 3 plus 4i, find the real numbers k and t such that w squared minus k plus t multiplied by w plus t equals 0. Okay, so the first thing that we want to do is substitute in our w into this equation. So now we're going to have 3 plus 4i squared minus k plus t multiplied by w plus t equals 0. Okay, so we might not know how it's going to turn out, but we just do it step by step. We expand and simplify what we can. So if we take our brackets, we have 3 plus 4i to be squared first. So we're going to multiply this out. So we square the first term, so that's 9, twice the product of the two terms, so that's 24i, and square the last, so that's 16i squared. Then we're going to multiply in these two brackets. For the moment, we're going to leave that minus sign on the outside. So k multiplied by 3 plus 4i first. We're going to get 3k plus 4ki. Now t multiplied by 3 plus 4i, so that's going to be 3t plus 4ti. And it's plus t is equal to 0. So we have 9 plus 24i. We must remember that I squared is equal to minus 1, so anytime this comes up we must change it. So that's going to be 16 now multiplied by minus 1, which will give us minus 16. Minus 3k minus 4ki minus 3t minus 4ti plus t equals 0. We have a lot of different terms here, and we have two unknowns. So we have k and we have t. So let's see if we can simplify a little bit further. 9 minus 16 is going to give us minus 7 plus 24i minus 3k minus 4ki. We also have minus 3t plus t, so that's going to give us minus 2t, and minus 4ti equals 0. At this stage, we want to create two different equations out of this. So we're going to put the real parts together and the imaginary parts together. So if we take the real parts first, it's going to be minus 7 minus 3k minus 2t, and they will all be equal to 0. And then for the imaginary parts, we're going to have 24 minus 4k minus 4t is equal to 0. So we just notice we've just taken the imaginary part of the number. We're not including the I at this stage. Now we have two equations with two unknowns. When that happens, we should remember that we solve these equations simultaneously. So I'm going to write these out again. So we want to solve them simultaneously. I'm going to multiply the top line by minus 2. So I'm going to get 6k plus 4t is equal to minus 14. The bottom line I'm just going to leave the same. Now I will notice that my t's are going to cancel. So plus 14 minus 4t is just going to give me 0. So 6k minus 4k is going to give me 2k is equal to, so minus 14 minus 24 is going to give me minus 38. So k is going to be equal to minus 38 divided by 2, which is going to give me minus 19. Now I use this value to find t. So I take one of the equations, doesn't matter which one, and I'm going to fill in the value that I found for k. So it's minus 3 multiplied by minus 19 minus 2t is equal to 7. So minus 19 multiplied by minus 3 is going to give me 57. Minus 2t equals 7. So now I have minus 2t is equal to 7 minus 57. So minus 2t is going to be equal to minus 50. So t is going to be equal to 25. So from one equation that I simplified, I made two new equations with k and t. So the first equation was the real parts, the second equation was the imaginary parts. Then I solved them simultaneously to find k and t. If you ever have a question like this where you're looking for two different variables, you should try and solve them simultaneously. So just to recap, we started with one equation and we created two equations by letting the real parts be equal to 0 and the imaginary parts be equal to 0. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.